This video is to cover a string function overview in the AP Java subset. What you'll need to know for the AP exam is all of these functions for string. String length, trim, equals, ignore case, index of, substring, and compare to. So I put together a real quick demonstration, and we'll kind of walk through this and point out key pieces of what string functions you'll need to know and how it works. So let's start off, shall we? Alright, we'll start off with this, the function length. Now length will give you the number of characters within a string. That will also include all the spaces as well, both the leading and trailing spaces as well as the spaces in the middle. So if I was to figure out how many characters are in count me, 1, 2, 3, 4, 5, there are 5 characters there. And in this one, count me 2, 1, 2, 3, 4, 5, 6, 7, 8. There should be 8 characters. So if I was to step my way through this, you can see I'm going to print out down here. The length of this is 5, and the length of this is 8. That's pretty straightforward. Notice that it's a function of the string, so you would start and end it with parentheses, and you're not passing any values in. You're just taking the string object and you're calling the length of that string object. Notice there's 2 different objects. We're calling the length of each different string. Moving on to trim. Trim does kind of what it says. Essentially it trims all the white space. So that could be space characters, it could be tab characters, it could be new line characters. Anything that's a white space character, like tabs, spaces, and new lines, they'll get trimmed off. So here I have a whole bunch of leading and trailing spaces, and also notice that there's spaces in the middle. This trim function will only trim off the leading and the trailing spaces. So here's an example of what it would look beforehand. We'll print that out. So here you can see it printed out the whole leading and trailing. And now if we printed off a trim, we notice it trimmed those values. It kept the spaces, the white space in the middle of the string, but it trimmed the leading and trailing spaces. Now, one thing I noticed when I was helping some people, is that the string functions do not change the actual string object. Some people tried to trim it by just calling trim and thinking that it would actually change the value of the string. It does not actually do that. Any function that you call for string does not modify the string itself. It only returns another string. So this, if you look at the definition for trim function, it actually returns another string. So to give you an example of this, here's another string which has leading and trailing spaces. Now if I step through this, you can see here we are before with the leading and trailing spaces, and now I'm going to call that function, and now I'm going to show what it looks like after I call that function. It's the same thing. Nothing happened to that string. If I actually wanted to change that string, I actually have to set it equal to the trim of the other string. So here you can see I'm calling trim. I'm going to set that string to that value. So now that I set it, I'm going to print it out again, and bam, it's trimmed. Okay, here's the next 2 functions we're going to cover is equals and equals ignore case. So if you're familiar with string, it is legal to use the equals value. To say, string 1, string start equals with the double equals, and say string compare. However, this is not comparing strings like you would think it's comparing strings. It's actually comparing memory locations. So as there is a pointer in memory to where start is, there's also a pointer to where string compare is. If I said this equals that, it'll try and say, okay, location A equals location B, and that doesn't work out. In Java, you actually have to call the equals function, where I take one string and pass in the other string. So here you can see there's a function called equals on the start string object, and I'm passing another string object to do the comparison. So here I have two two strings, donut and donut with a GH, and if I compared them, they should not equal. This will return back a Boolean, which is either true or false. Either it is or it's not. You can see that donut without a GH does not equal, is false. It does not equal donut with a GH. My next try, I'm actually going to make something that will work. Donut should equal donut. We'll try this out. Sure enough, donut equal donut is true. Now, one of the things equals does not do is it does care about leading and trailing spaces. So if I don't trim this, here's donut with trailing spaces. If I compared it, it will say they do not equal. Here you can see donut with spaces does not equal donut without spaces. That's one thing to be aware of. Make sure if you're ever comparing two strings to use the trim feature so you trim the leading and trailing spaces. And finally, here's donut, but it's donut with a lowercase d. Now when I call the equals, it will say these are two different strings. And we'll proof that out. Here, I'll run it down. Donut with a capital D does not equal donut with a lowercase d. Now, there is a function called equals ignore case, where it will actually ignore the casing of the characters. So in this case, where I have donut uppercase and lowercase, it will work out. So ignoring the case, donut equals donut. Doesn't matter about the casing. The next function we'll cover is index of. So here is a sentence. I like a bowl of spaghetti. I'm going to find the word like, the word bowl, and the word Big Bird. You can see that like exists, bowl exists, but Big Bird does not exist. So if I run this through, we can see that like is found in character 2, 0, 1, 2. It starts on character 2. Bowl starts on character 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So here I can see bowl is found in that sentence, but Big Bird is not found. Big Bird doesn't exist anywhere. And if that value is not found in the string, it'll return a -1. So that's the way you can determine to see if a string holds another string. If it doesn't, it'll have a -1. The next thing is the two substring functions that you will care about. The first substring function essentially says I want to get a piece of a string. So here's another sentence. I like to teach the world to sing. I don't really care about the start of this. I just want to grab the end of this. So I just want to grab the rest of this. So the first substring is where I will say start at character 4, which is the L, and just grab the rest of the string. So here, if I step through this, you will see that I only grabbed the last part of that string, just to like to teach the world to sing. Now, if I wanted to get creative and I just wanted a piece, the middle piece of that string, like say instead of that, I just want the word like, I want the two words like to. So I'm going to start at character 4 and end at a character 11. So if I run that, if I step to that, sure enough, I get the words like to. 4, 5, 6, 7, 8, 9, 10, and stop at 11. I'm only getting this substring. Now the last function is a little more complex because it compares two different strings lexicographically, which you'd think it's alphabetically, but it's not. It's just slightly different. It basically compares the Unicode value, or the ASCII, if you're familiar with ASCII value, of each character in the string. So on the face of it, you think that I know that apples, in the dictionary, apples will come before bananas. So if I call the compare to feature and the one I'm comparing to comes after, it should be less than 0. So it would be a negative number. If they equal each other, all the characters match the same, are the same ASCII values, it'll equal 0. And if it's greater than, say I switch these around, it'll be greater than 0. So here I'm going to compare apples and bananas. So here I'm setting it. Now I know that when I call apples and I pass bananas into apples, that it'll be less than 0 because apples is less than banana, because capital A is less than capital B in the ASCII code, in the ASCII table. Control Z. And sure enough, I see that apples, it goes into that if statement, apples is less than bananas. Now I'm going to compare apples to apricots. Now it'll compare the first characters, A to A, capital A and that capital A match. I'll compare the second letters, P is the same thing as lowercase p, those match, but lowercase p does not match lowercase r, and r comes after that in the ASCII chart, so apples will be less than apricots. So we go take a look. Sure enough, apples is less than apricots. So now I'm going to compare apples to apples. Same number of characters, same casing of characters, everything is the same. So I should expect this compare to function to equal 0. Now notice I'm not saying one string is less than or greater than another string. I'm using the compare to feature, and depending on whether it returns less than 0, equal to 0, or greater than 0 will tell you where it's at. Now here's the kicker. You would think that apples with a proper case A, with an uppercase A, would be the same thing as lowercase a. However, I know that apples lowercase a is after, because capital A is less than A in the ASCII chart. And let's bring up the ASCII chart here. So here we can see that the value for capital A is 65. The value for lowercase a is here later in the chart is 97. So it compares all these different characters, and if one character is lower than the other character on the ASCII chart, it'll return less than 0 or greater than 0, depending on where it's at. This concludes the demonstration. I hope this was instructive.